Hello kids. In today's class, we will start with the next topic, equivalent decimals. So, what are equivalent decimals? For that, I'm going to take one example. Example which I'm taking here is 2 by 10, 2 by 20 by 100 and 200 by 1000. Okay, so kids, you see, if we express these numbers into decimal, they will be written as 0 0.2, 0 0.20, 0 0.200, for the reason that here we have only one zero in the denominator, so decimal will be placed after one place. Here we have 2, so 2 places. Here we have 3, so 3 places. But when you see all these numbers 0 0.2, 0 0.20 and 0 0.200, the value of all the three numbers are same. So what I'm saying is value of 0 0.2 is equal to value of 0 0.20, which is also equivalent to value of 0 0.200. Right? How? See, let us solve these numbers given to us, the fractions. 2 by 10 can be written as 0 0.2, which we have already written here. 20 by 100, if you just try to solve it, we can always cut these two zero, and what is remaining is again 2 by 10, which is nothing but 0 0.2 again. Correct? Similarly, we have 200 divided by 100, 1000. So when we are trying to solve it, we can cut these two zeros with the denominator, and the left part is 2 by 10, which is again equivalent to 0 0.2. Right? So what we see here is that 0 0.2 is equivalent to 0 0.20, and this is also equivalent to 0 0.200 zeros. So which, using this, we can also say that writing or removing the zeros at the end of a decimal number doesn't changes its values. Okay, because here I have added 1 0. This is the end of the number. After this, we do not have any number from 1 to 9. We have only 0. So if we are writing 0 at the end of the decimal number, always remember end of the decimal number, the value will not be changed. Okay, so I am taking another example here. Let me erase this, and now I am taking another example here. See, I have a number 0 0.5. Okay, and this means if I write it in fractions, this will be 5 by 10. Now this 0 0.5, after decimal, this is the last number. Beyond this, there is no any other number. Okay, so what I can do is I can add 1 0 to it. Okay, so now when I'm adding 1 0 to it, this will become 50 by 100. And if I'm solving this, this will become 5 by 10. That is same. Okay, so also what can I do is I can add two zeros here. So when I am adding two zeros here and changing it into fraction now, this will again be 5 by 10 upon solving. Also, if I go further and add three zeros to it, so this will become 500 divided by 1, 2, 3, 4 zeros in the denominator. And when I am solving this, this will again become 5 by 10. So what we can say is that if we add or remove zeros from the end of a decimal number, it doesn't change its value. The value will be same. Okay, but it is always at the end. It should always be done at the end. This is end, this is end. So if this is end, I can add any number of zeros to it, only to the decimal number. But if I have any number such that, let's say I have a number 0 0.52, I cannot add any zero in between. I cannot make this as 0.502. This will be completely wrong. I can always add the number at the end. I can make it as 520. I can make it as 0.5200. I can make it as 0.520000 something. That means you can always add zeros at the end. Okay. Similarly, we can also remove zeros from the end. There are certain scenarios in mathematics where we will get many questions where we have to make the given decimal number equal, given decimal number like. So we are going to learn the concept of like and unlike decimals now. But before that, I just want to again tell you that how what are equivalent decimals. So these are the decimal numbers which have the same values. Okay. Example 0 0.7, 0 0.70, 0 0.700, 0 0.7000. All these are equivalent decimals because when we solve them, we will get the same value. Okay. Their value is same. Remember, their value is same. So this was about equivalent decimals. Next, we have concept of like decimals and unlike decimals. Okay. So kids, like decimals are the decimals which have same number of decimal places. So I'm writing here, they are the decimal numbers. They are the decimal numbers having same number. Here we are talking about number and not the value. Okay. Same number of decimal places. So let us understand what does it say. They are the decimal numbers having same number of decimal places. So I'm taking two numbers here. Let me take 1.62. This is one number I'm taking. Next, I am taking 2.74. Okay. These two are completely different numbers with different values. They are decimal numbers. First, they should be decimal numbers. They are decimal numbers because they contain decimal. Also, their values are totally different. What we have to see whether these numbers are like decimals or not. So we say the decimal numbers are like decimal numbers if they have same number of decimal places. So here the number of decimal places are 2. Yeah, this is 10th place, this is 100th place. And if we see here also we have two decimal places, 10th place and the 100th place. So since the number of decimal places are same, these are like decimals. Okay, these numbers are like decimals. If I take another example where I have 3.578 and 1.3, let's say. So these are decimal numbers, they have different values, but when we see if they are like or not, we will compare their places, number of places after decimal. So here number of places are 10th, 100th and 1000th. That is, we have 3 decimal places. And in this number, we have only one decimal place, which is 3, which is at the 10th place. So that means these numbers do not have same number of decimal places. They are unlike decimals. Okay. We call them as unlike decimals. The numbers which have same number of decimal places, they are like. The numbers which do not have same number of decimal places, they are unlike decimals. An examples we have just seen here. Okay. So I hope you have understood that in the case of like and unlike decimals, we have to compare the number of places and not the values. Again, I am insisting on this, not the values, but only the number of places. Okay. But in the case of equivalent decimals, we have learned they are the decimal numbers which have same value. Okay. they have same value. The number of places might be different, but the value of all these numbers are same, right? Now kids, what we are going to learn is that if we are given with any unlike decimal, how we can convert that into like decimal. Let's do this. I'm just erasing it fast and convert unlike, sorry, unlike to like decimals. Okay. Okay. I'm taking example. Let me take, I have 2.57. Another number, I have 4.8. Okay. Now, see, both of these are decimal number with different values. Also, when we compare the number of places, here we have two places, 10th and 100th. Here we have only one place, 10th place. So that means they are unlike decimals. Now what we have to do is we have to make them like. So for that, what we have to do is we have to make their number of places same. Okay. So 2.57 is the number which is having greater number of places, of decimal places. Okay. How many? 2. And 4.8 is a number which has only one decimal place. So if we have to make these two numbers, these two decimal numbers into like, what we have to do is we have to increase the decimal places in this number 4.8. Why? Because it has less number, and to make it equal to the bigger number we have to add more places to it. And kids, as we have learned the concept of equivalent fractions, we have understood that if we add or remove zeros at the end of decimal number, then the value is same. So what I can say is I can write 4.8 as 4.80. When I am writing 4.8 as 4.80, the value is same, right? But the number of decimal places is now increased to 2. So the number of decimal places of this new number 4.80 is equivalent to the given number 2.57. So now again I am writing 2.57 and 4.80. These are the like decimals. So understand what we have done to make unlike decimal to like decimal. First of all, find out what are the number of decimal places in the given numbers. First part, that is the first step. Second step is we have to see that what is the number which is having the greatest number of decimal places. So in our case, it was this number. It had 2 decimal places. So that means for the remaining numbers, or the which is only one number given to us here, we have to increase this number to the 2 decimal places. So for that we have added 0 at the end of it, right? We have made the equivalent decimal number of 4.8, that is 4.80. We are adding 0 at the end. So when we are doing this, we have got 2 decimal places which is equivalent to the given number 2.57 also. So now these two numbers are the like decimals. Okay. So now I hope this is understandable to you. Again, I'm taking another question. Let me take another question. Let us take 8.73 and 0.679. Let's say. Okay. So now kids, you see these are two completely different numbers with different values, and let us see if they are like or not. Okay. So here we have 2 decimal places and here we have 3 decimal places. So obviously these are unlike decimals. Okay. Because the number of places are different. Now, which is the number which is having the greater number of decimal places? This is the number. 0.679 is the number which is having 3 decimal places. So what we have to do here is we have to take the other number and we have to increase its decimal places. The given number is 8.73. We will take its equivalent decimal number. We will add 10 to the end of it so that we get 3 decimal places. So we have changed 8.73 to 8.730. The value is same, but the number of places is more, which is 3 here. So now 8.73, 0 and 0.679 have become the like decimals because they have the same numbers of places. Okay, so kids, this is how we have to convert. We have a whole exercise based on it, which we are going to cover in the next class. And I want you to go through these 2 examples and try to take more example yourself and solve it. And we will pick the exercise based on this in the next class. So I will see you all in the next class now. Thank you.